Hello and welcome to the channel Science, Maths and Engineering. Today we are going to solve the GATE 2011 Mechanical Engineering paper part 1. So let's get started. Question number 1. A streamline and an equipotential line in a flow field are A. Parallel to each other, B. Perpendicular to each other, C. Intersect at an acute angle, or D. Are identical. So the answer is B. A equipotential line and a streamline are perpendicular to each other. So what is the equipotential line? Equipotential line is a line where the velocity potential is constant. Now velocity potential is a function of x and y. So phi is a function of f of xy. So d phi would be equal to del phi by del x dx plus del phi by del y dy. So from here we got d phi is equal to minus u dx minus v dy. Now, so as it is equipotential, so velocity potential is constant, so d phi is constant, so d phi is 0. So minus u dx minus v dy is equal to 0. So which implies that dy by dx for equipotential line is equal to minus u by v. Now dy by dx is the slope of the line, so slope of the equipotential line is minus u by v. Next, streamline is where the stream function psi is constant. Now psi is again a function of x and y. So d psi is equal to v dx minus u dy. From here we get dy by dx for a streamline is v by u. Okay. Now that is again the slope of the streamline. So if we multiply both these slopes, that is dy by dx for a streamline into dy by dx for equipotential line, then we get minus 1. Now from mathematics we know if the slope of two lines, if the product of the slope of two lines is minus 1, then the lines are perpendicular to each other. So the streamline and the equipotential line are perpendicular to each other. Okay, so we'll go to the next question. If a mass of moist air is in an airtight vessel is heated to a higher temperature, then A. Specific humidity of the air increases, B. Specific humidity of the air decreases, C. Relative humidity of the air increases, or D. Relative humidity of the air decreases. So the answer is D. Relative humidity of air decreases. Now we can see that specific humidity omega is what mv by ma, that is mv is the mass of the water vapor in mixture and ma is the mass of dry air in mixture. Now in the question it is said that the air is in a airtight vessel. Okay, so the mass of water vapor and the mass of dry air are both constant, so specific humidity remains constant. Now relative humidity phi is what? M by mvs, where m is the mass of water vapor in a given volume and mvs is the mass of water vapor in the same volume if saturated at the same temperature. That means mvs is the mass of, is the capacity of the air to hold how much mass we can have. So means mvs, if the temperature increases, what will happen is that the capacity of the air to hold more water vapor increases, then so that it is saturated, so mvs would be more as temperature increases. However, as m is the mass of water vapor in a given volume, so it remains constant as it is an airtight vessel. So our relative humidity phi equal to m by mvs. Now m remains constant, mvs increases, so relative humidity decreases. Okay, so we'll go to the next question. In a condenser of a power plant, the steam condenses at a temperature of 60 degrees centigrade. The cooling water enters at 30 degrees centigrade and leaves at 45 degrees centigrade. The logarithmic mean temperature difference of the condenser is A. 16.2 degrees centigrade, B. 21.6 degrees centigrade, C. 30 degrees centigrade, or D. 37.5 degrees centigrade. Okay, so this is a problem from heat exchanger. So the answer is B. 21.6 degrees centigrade. So here I am drawing the temperature profile. as it is condensation, so the temperature of the steam condensing remains constant. It loses latent heat, but temperature remains constant. Now, this Tc1 is the temperature of the water, cold water inlet, and Tc2 is the temperature of the cold water outlet. So, the difference of the Th minus Tc1 would be delta Ti, that is inlet temperature difference, and Th minus Tc2 would be the delta Te, that is outlet temperature difference. Now we know log mean temperature difference is equal to delta Ti minus delta Te divided by log of delta Ti by delta Te. We already have Th, which is 60 degree, Tc1 is 30 degree, and Tc2 is 45 degree. So delta Ti is Th minus Tc1, which is equal to 30 degree, and delta Te equal to Th minus Tc2, which is equal to 15 degree. So we have delta Ti and delta Te. So log mean temperature difference would be 30 minus 15 by log of 2, which is equal to 21.6 degrees centigrade. So we'll go to the next question. A simply supported beam PQ is loaded by a moment of 1 kilonewton meter at the midspan of the beam as shown in the figure. The reaction forces Rp and Rq at supports P and Q respectively are A. 1 kilonewton downwards, 1 kilonewton upwards, B. 0.5 kilonewton upwards, 0.5 kilonewton downwards, C. 0.5 kilonewton downwards and 0.5 kilonewton upwards, or D. 1 kilonewton upward and 1 kilonewton upward. So both are upward. So the answer is A. That is, the Rp would be 1 kilonewton downward and Rq is 1 kilonewton upward. So for that, what we do, initially we take Rp and Rq both in the upward direction. These are the reactions. Now we have a moment 1 kilonewton meter in the clockwise direction, and this moment and these two reaction forces they together keep the system in equilibrium. Now as the system is in equilibrium, so summation of Fx equal to 0. However, here is no force in the x direction, so that we are not considering. Then we have summation of Fy equal to 0. So here Fy equal to 0, we have Rp plus Rq equal to 0. Okay. Next we have summation of the moments equal to 0. Now if we take all the moments about point P, then we have Rq into 1 meter. This would be in the anti-clockwise direction, so it is positive. Minus 1 because of this minus 1, that is clockwise direction, so it is minus 1. Plus, if there had been any other force, or if we take this Rp force into, but the distance is 0, so the Rp force, there is no moment, so that gets cancelled out. So Rq into 1 minus 1 equal to 0, that is Rq equal to 1 kilonewton. So Rq direction is upward only and its value is 1 kilonewton. Now Rp from this equation, Rp plus Rq equal to 0 would be Rp is equal to minus 1 kilonewton. That means Rp's direction is wrong. So Rp would be downward. Thus the reaction forces are 1 kilonewton downward and 1 kilonewton upward. So we'll go to the next question. A double parallelogram mechanism is shown in the figure. Note that PQ is a single link. So the mobility of the mechanism is A minus 1, B 0, C 1 or D 2. So the answer is C 1. Now if we see the figure, the number of links is 1, 2, 3 and this PQ, that is 4. So number of links N is 4. Then number of links having 1 degree of freedom would be again 4, and there is no link that has 2 degree of freedom or more. So P2 or P3 all are 0. So P3 here I am not showing in the equation as we have no pair with 3 degree of freedom. So our F is equal to 3 into n minus 1 minus 2 into P1 minus 1 into P2. So from here we get F is equal to 1. Okay, so we'll go to the next question. The maximum possible draft in cold working of sheet increases with the A. Increase in coefficient of friction, B. Decrease in coefficient of friction, C. Decrease in roll radius, or D. Increase in roll velocity. Now, so the solution is A. It increases with the increase in coefficient of friction. So we have this equation for draft, that is maximum draft is equal to mu square into R. Here mu is the coefficient of friction. So as mu increases, maximum draft increases. However, we also have R, that is the roll radius. But as roll radius increases, the maximum possible draft decreases. As we do not have any option for increasing roll radius, so we have only one option, that is as the coefficient of friction increases, the maximum draft increases. So we'll go to the next question. The operation in which oil is permeated into the pores of a powder metallurgy product is known as A. Mixing, B. Sintering, C. Impregnation, or D. Infiltration. So the answer is C. Impregnation. So this mixing, sintering, impregnation, infiltration, these are all processes of powder metallurgy. Okay, so what we have is that initially powders of different substances are combined by mixing. It is done through some mechanical means that I mentioned. Drum rotates, so that is there. So we mix it. Basically, we mix it, and then what we do, we press it by using dies. So we press it and make it hard. However, it doesn't have the strength. So we do heat treatment called sintering, where we heat it between 0.7 to 0.9 times on the metal's melting point in Kelvin, and then there are some bonds, surface area decreases, and there are some formation of bonds, and so the metallic bonds are being made, and this increases the strength and hardness. Now next we do impregnation, where oil or other fluid is permeated into the pores of a sintered powder metallurgy part. Now if we do not do impregnation, what we can do is that pores of this powder metallurgy product may be filled with some other molten metal. Now this molten metal will have a melting point lower than the powder metallurgy part. So if this molten metal goes inside the powder metallurgy part, then it is known as infiltration. So our answer is impregnation. However, I tried to give you a gist of all the other options so that it is easier to differentiate in future questions. So we'll go to the next question. A hole is of dimension phi. Upper limit is plus 0.015 upper tolerance, and lower tolerance is plus 0 mm, and the corresponding shaft is of dimension phi is upper tolerance is plus 0.010 and lower limit is plus 0.001 mm. The resulting assembly has A. Loose running feet, B. Close running feet, C. Transition feet, or D. Interference feet. So the answer is C. Transition feet. So if we see the minimum permissible diameter of the shaft, it is 9.001 mm, and the maximum permissible diameter of the shaft is 9.010. Similarly, minimum diameter of the hole is 9, and maximum allowable diameter of the hole is 9.015. If we see in this maximum allowable diameter of the hole 9.015, the minimum permissible diameter of the hole, that is 9.001, fits with a clearance. So if minimum shaft diameter and maximum hole diameter is there, then we have a clearance fit. However, if we have the maximum diameter of the shaft, that is 9.010, and minimum diameter of the hole, that is 9, then what we can see is that shaft is bigger than the hole. However, this this is not so big, so we may have this fit, but we have to apply some force or pressure. So this kind of fitting is known as interference fit. Okay, now whether the assembly would be a clearance fit or interference fit, it depends on the actual size of the part. Okay, because we don't know whether it will be means in which limit it will be there. We don't know it. After we produce this, only then we know that okay, this has some clearance fit or some interference fit. So this kind of assembly is known as transition fit. Okay, so we'll go to the next question. Heat and work are A, intensive properties, B, extensive properties, C, point function, or D, path function. So the answer is heat and work are path function. See, this is a PV diagram and we have 2 points 1 and 2. Now the area under this curve 1, 2 gives us the work done by the process. However, from 1 to 2 we can go through different routes like through A, through B or C. And as work done is the area under this under the curve 1, 2, so the curve 1, 2 as it varies as we take the different parts, so the work done also varies. That means the work done depends on the path of the curve, so that is why it is known as a path function. Similarly, heat transfer also depends on the intermediate states through which the system passes, and thus it is also a path function. Okay, so we'll go to the next question. A column has a rectangular cross section of 10 mm by 20 mm and a length of 1 meter. The standardness ratio of the column is close to A 200, B 346, C 477, or D 1000. So the answer is B 346. So as we have this rectangular cross section 10 by 20, so D is equal to 10 and B is equal to 20. Now slenderness ratio is L by K. Now length we are given that is 1 meter, that is 1000 mm. Radius of gyration K is equal to root over minimum moment of inertia divided by A. Here the minimum moment of inertia would be BD cube by 12, which is BD cube by 12 we are taking. Then area is B into D. Therefore K would be root over BD cube by 12 and divided by BD. So we get D square by 12, root over D square by 12, which is equal to 2.886 mm. Therefore slenderness ratio would be 1000 divided by 2.886, that is equal to 346.5 or approximately 346. So we'll go to the next question. A series expansion for the function sine theta is, we have different options. So the answer is the series expansion for the function sine theta is theta minus theta cube by 3 factorial plus theta over 5 by 5 factorial minus and so on. However, if this is option B. Now option A, that is 1 minus theta square by 2 factorial plus theta over 4 by 4 factorial minus and so on, that is the series expansion for the function cos theta. Okay, so we'll go to the next question. Greens and mold indicates that A, polymeric mold has been cured, B, mold has been totally dried, C, mold is green in color, or D, mold contains moisture. So the answer is that green sand molds are a mixture of sand, clay and water, and the word green indicates that the mold contains moisture. The mold contains moisture. So it is option D. Next question. What is limit theta tends to 0 sine theta by theta equal to? So the answer is 1. Limit theta tends to 0 sine theta by theta. Here if we put theta equal to 0, we get that both numerator and denominator are 0. So in such cases we use L'Hospital's rule and we differentiate numerator and denominator. So as we differentiate, we get limit theta tends to 0 cos theta by 1. So theta, when you put 0, so cos theta is 1, so 1 by 1 is 1. So limit theta tends to 0 sin theta by theta is equal to 1. So we'll go to the next question. Eigenvalues of a real symmetric matrix are always A positive, B negative, C real, or D complex. So the answer is eigenvalues of real symmetric matrix are always real. However, if we have skew symmetric matrix, then the eigenvalues are pure imaginary or 0. So we'll go to the next question. A pipe of 25 mm outer diameter carries steam. The heat transfer coefficient between the cylinder and the surroundings, that is H, is 5 watt per meter square Kelvin. It is proposed to reduce the heat loss from the pipe by adding insulation having a thermal conductivity of 0.05 watt per meter Kelvin. Which one of the following statements is true? A. The outer radius of the pipe is equal to the critical radius. The outer radius of the pipe is less than the critical radius. C. Adding the insulation will decrease the heat loss. D. Adding the insulation will increase the heat loss. Now we have thermal conductivity of the insulator. Ki is 0.05 watt per meter Kelvin. Heat transfer coefficient we already know, 5 watt per meter square Kelvin. So for a pipe or tube or wire, critical radius of insulation R naught critical is equal to Ki by Ha, which is equal to 0.05 divided by 5 in meter, which is equal to 10 millimeter. The outer radius of the pipe R naught is 12.5 millimeter. So as outer radius is greater than critical radius, so as insulation or R naught increases, heat loss decreases. So we'll go to the next question. The contents of a well-insulated tank are heated by a resistor of 23 ohm in which 10 ampere current is flowing. Consider the tank along with its contents as a thermodynamic system. The work done by the system and the heat transfer to the system are positive. The rate of heat, work, and change in internal energy during the process in watt are. So the answer is, we have resistance R is 23 ohm, current I is 10 ampere. So the power is P is equal to I square R, which is equal to 2300 watt or 2.3 kilowatt. Now increase in internal energy del E is equal to heat dissipated by the resistor. Therefore delta E is plus 2.3 kilowatt. As no heat transfer took place on the system or by the system, so Q is equal to 0. It is well insulated wall. Now Q minus W is equal to delta U. It is from the first law of thermodynamics. Therefore W is equal to Q minus delta U is equal to 0 minus 2.3 kilowatt or minus 2.3 kilowatt. Therefore Q is equal to 0, W is equal to minus 2.3 kilowatt, and delta U is equal to plus 2.3 kilowatt. So it is option A. So we'll go to the next question. Match the following criteria of material failure under biaxial stresses sigma 1, sigma 2 and yield stresses sigma y with their corresponding graphical representations. So these are basically graphical representations, and so the answer is C. Here figure L represents maximum shear stress criteria, maximum shear stress theory. So then figure M is corresponding to the maximum normal stress criterion, and figure N corresponds to maximum distortion energy criterion. So we will go to the next question. The product of two complex numbers 1 plus I and 2 minus 5i is, so we need to multiply these two complex numbers and we will get the answer. So the answer is A. So 1 plus I into 2 minus 5i is equal to 2 plus 2i minus 5i plus 5, as I square equal to minus 1. So we have 7 minus 3i. Okay. So we'll go to the next question. Cars arrive at a service station according to Poisson's distribution with a mean rate of 5 per hour. The service time per car is exponential with a mean of 10 minutes. At steady state, the average waiting time in the queue is A 10 minutes, B 20 minutes, C 55 minutes, or D 50 minutes. Okay. So this is a question from the Q theory, which is in operation research. So the answer is, we have lambda is equal to 5 per hour, mu that is 10 minutes it takes, so in 1 hour it is 6 per hour. So average waiting time in the queue, WQ, is equal to lambda divided by mu into mu minus lambda, which is equal to 5 by 6 hour or 50 minutes. So at steady state, the average waiting time in the queue is 50 minutes. So we'll go to the next question. The word Kanban is most appropriately associated with A. Economic order quantity, B. Just-in-time production, C. Capacity planning, or D. Product design. So the answer is B. The just-in-time production. So Kanban is a Japanese word, and this just-in-time is a production technique where we try to achieve zero inventory within an organization as well as throughout the entire supply chain. And Kanban is one of such production technique where we use full system of production, that is, we produce on demand. So we'll go to the next question. If fx is an even function and a is a positive real integer, then integration minus a to a fx dx is equal to a0 b a c twice a, or d twice of integration 0 to a fx dx. So the answer is D, twice of integration 0 to a fx dx. So I have given the derivation of this, so you can go through it. And please note that if fx is an odd function, then the integration minus a to a fx dx would be 0. So we'll go to the next question. The coefficient of restitution of a perfectly plastic impact is A 0, B 1, C 2, or D infinity. So the answer is A 0. So coefficient of restitution is equal to velocity of separation divided by velocity of approach. And for a perfectly plastic impact, it is 0, and for a perfectly elastic body, it is 1. Now, as it is 0, that means for a perfectly plastic body, V2 is equal to V1. That is, the final velocity of both the bodies are equal. Although one body may have been faster than the other, so velocity of approach would not have been equal to 0, but the velocity of separation is 0. Okay, so u1 is not equal to u2, but v2 is equal to v1. Okay, so we'll go to the next question. A thin cylinder of inner radius 500 mm and thickness 10 mm is subjected to an internal pressure of 5 megapascal. The average circumferential, that is hoop stress in megapascal, is A 100, B 250, C 500, or D 1000. So the answer is B 250. So we know pressure P is 5 megapascal, diameter is 1 meter, thickness is 0.01 meter, and we know the hoop stress for a cylinder sigma c is equal to PD by 2T. So from here we get sigma c is equal to 250 megapascal. So we'll go to the next question. Which among the following welding processes uses non-consumable electrode? A. Gas metal arc welding. B. Submerged arc welding. C. Gas tungsten arc welding. Or D. Flux coated arc welding. So the answer is C. Gas tungsten arc welding, which is also known as tungsten inert gas welding. So it uses a non-consumable tungsten electrode to produce the weld. In all other methods, we use consumable electrode, and I have also given a gist of this welding technique so that it helps in the other questions and also to understand which why uh, what is there in the other options. Okay, so we'll go to the next question. The crystal structure of austenite is A. Body centered cubic, B. Face centered cubic, C. Hexagonal closed packed, or D. Body centered tetragonal. So the answer is B. Face centered cubic. So austenite is one of the crystal structure of Fe3C, and it is face centered cubic. There are other like martensite and some other crystal structures are there. So all have different structures and they have different properties. So that is why we try to understand the iron carbon diagram very carefully, and we use this iron carbon diagram to attain specific hardness or ductility based on the requirement. Okay, so this concludes the part 1 of the GATE 2011 mechanical engineering paper. Here the objective questions of 1 marks are being evaluated. With this we conclude this part 1. Thank you.